Okay? And so each time you multiplied pressure times volume, you always got the same number. K stands for constant. And a constant means it's the same number every time. Okay? Well, that means that if you have one pressure and one volume, and the next time you have a different pressure and a different volume, it's still going to equal K. And I hope it's not too much of a stretch that you should be able to see then that pressure 1 times volume 1, because it also equals K, and so does this one. Pressure 1 volume 1 equals pressure 2 volume 2. Does that make sense to everybody? Each time you change it, as long as you don't change the amount of gas, which means the number of molecules.
I need to put this in my folder.
I need to see it first. Yes, you do. Thank you. So as long as you don't change the number of molecules of gas and you don't change the temperature. And we didn't change the temperature yesterday. It stayed room temperature the whole time. Although, it's possible that some of you took your reading so fast there might have been a slight change in temperature, which may have been part of the reason why your answer for pressure times volume in some cases was slightly off. If you want to get really good answers, you're going to hold it at a new pressure, or new volume rather, and hold it there and leave it for a few minutes for the temperature to equilibrate with your surroundings. Okay, we didn't try to do that yesterday. But you probably got a slightly different answer sometimes because it was a little warmer inside. Okay, or even a little cooler inside. You might not even noticed it, but it was enough to affect the pressure times volume calculation. Or simply the instrumentation wasn't as accurate as it could be. Okay? Everybody clear with that? All right. So that gives us a way of solving gas law problems. Let's see, we did one of these yesterday, didn't we? In class before you left? Yeah. So y'all should be able to do this one. Let's do this one individually, okay? Then, this is a class practice problem. Mm-hmm. Okay? So if a gas is held in a cylinder under a piston and the piston has no friction and the temperature doesn't change, what will the pressure become if the beginning pressure is 2.50 atmospheres, the beginning volume is 25.5 milliliters, and then the piston is compressed so that the final volume becomes 12.25 milliliters. So that's your practice question. Remember, there's a specific way that I require that you solve these problems. Okay? List your knowns and unknowns with the variables, or the symbols that represent variables. Write out the equation you need to solve the problem. Substitute known values into that equation. And finally solve, showing all the steps.